Okay, so also what's up? You want help with exponents? Guys, please support my live goal there. Support my live goal, please. So what do you want with exponents? You said you want help with exponents. What about? What grade are you in? And what do you want help with specifically? When am I live again? I always go live in the morning like this. Okay, so you first said exponents, now you're saying grade 10 algebraic fractions. What part of algebraic fractions? There's multiplication and division, there's addition and subtraction. Which one? Okay. Okay. Can we do this question, bravos? You're in grade 10 and you're calling yourself bravos. What in the world, bro? What's up with that? Okay. This subtraction, addition, algebraic fraction. Can we start here? Or do you want another one that's more? Would you be able to do this? Yes, which is what? You tell me, what is the LCT here? Four. So firstly, let's look at how many terms we have. We have 1, there's a minus sign, 2, a plus sign, 3. Okay, and then let's establish what are the denominators of all the terms. So 3x is written as just a number, as a term. So we are going to say 3x over 1. Okay, x cubed minus 2 has the denominator 4x squared, and the denominator and 1 over 12x has the denominator 12x. So when we look for the lowest common multiple, if the denominators have been factorized, we need to ask ourselves, what is the lowest common? Remember, LCD comes from the concept of LCM, lowest common multiple. So you have the number, okay, and here the numbers are 1, 4, and 12. So the question is, what is the lowest common multiple between 1, 4, and 12? Let us establish first what is the lowest common multiple number. So tell me, Bravoza, what is the lowest common multiple between 1, 4, and 12? Let's start there. Comment in the comment section. No. Are you in grade 10, Bravoza? Because if you are, then in grade 7, grade 8, and grade 9, you learned about the lowest common multiple. So 1, 4, and 12. Do you know what a multiple is? So if you count in ones, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. These are multiples of 1. If you count in fours, 4, 8, 12. These are multiples of 4. If you count in 12s, 12, 24, 36, and so it goes. So what you want is you want to establish what is the lowest common multiple between 1, 4, and 12. So if you look at 1, you look at the multiples of 1, multiples of 4, multiples of 12. What is the lowest number that is common to all three numbers? So, okay, you see, it's 12. So I think your problem lies there. You don't know how to get the lowest common multiple between your numbers. So the lowest common multiple is what? Is 12. The first common number, that is the multiple that appears between 1, 4, and 12, is 12. Okay. So we write 12 for our lowest common multiple number. Let's move on. Now we are going to move away from the number and we are going to move to, so N stands for number. L means the letter of the alphabet, the variable. So now we are going to look at the first fraction has 1 as the denominator, there's no letter. The second fraction has x squared as the denominator. The third fraction has x as the denominator. So now we are looking for the lowest common multiple letter, and that letter is the common letter with the highest exponent. The common letter with the highest exponent. I repeat, the common letter with the highest exponent. So x, we agree, is not common for all three numbers or for all three fractions, but it is a letter that is there. It is unique. So what we want to then establish is between x squared and x, as it is the leftover letter, which letter has the highest exponent? Since x and x are common for these two fractions, which letter, is it x squared or x, that has the highest exponent? Because we include that in our lowest common denominator. So which one is it? X squared or x? The letter with the highest exponent, which one is it? X squared. So then we are going to multiply the n that we got, the lowest common multiple number, with the lowest common multiple letter, the common letter with the highest exponent. This letter doesn't have to be common for all three fractions. because x is unique for two fractions in the denominator, and we choose the variable or the letter of x that has the highest exponent, and we multiply it to the number. Then we move on to the last thing. After identifying the lowest common multiple letter, we go and identify the lowest common multiple bracket. But here in these denominators, we don't have common brackets. If we did, we would go for the common or unique bracket with the highest exponent. But we don't have that. So that means our LCD is 12x squared. Are you with me now? Browser. Okay. So when you asked me to help you with addition of algebraic fractions, you must admit that you did not know how to identify the LCD. And I am telling you that is where the downfall of most students is. They can't identify the LCD. So please remember next time that when you identify the LCD, it is the product or the multiplication of the lowest common multiple number. So you look at the 1, the 4, and the 12, the coefficients of the variables. You look at the 1, the 4, and the 12. Remember, we did not have the 1 there. We put the 1 there because we saw that 3x can be written as 3x over 1. Then we identified the lowest common multiple as 12 because the multiples of 1, 12, multiples of 4, 4, 8, 12, and multiples of 12, 12, 24, 36. The lowest number that is common for all three numbers is 12. We then identify the lowest common multiple letter between x squared and x. We choose the common letter with the highest exponent. So that means we multiply the 12 with x squared. Then if we had a common multiple bracket, we would also write that down. We identify the common or unique bracket with the highest exponent, and we include it in the product if we had one, but we don't. So we know that the LCD is 12x squared. Now, the next thing, after we identify the LCD, we have to do what? Browse. What do you know? What do we do after we've identified the LCD? I'm waiting here for you to comment because you are the one that asked the question. You must be the one that tells me. Factor out the fractions. I don't understand what you mean by that. You've already gotten the LCD, so what do you mean by factor out the fractions? It's a pity that you don't have privileges on TikTok to speak. Join as a guest and speak, because it would be quicker if you were able to do so. Factoring out the fractions, I don't understand what you mean by that. Okay, factor out the fractions. Okay. Divide the denominator into the LCD. Okay, so speak to me. Therefore, what does that mean? Be practical. So, what am I going to do next then? Speak to me. I'm listening. Because remember, we are adding and subtracting fractions. There's a rule that governs addition and subtraction of fractions. You can never add fractions or subtract them if the denominators are still the same. Okay. So what we need now is we need to form what we call equivalent fractions. An equivalent fraction is going to be the fraction for each fraction here that basically will have this LCD. Right. So with the one that we have here, we are going to ask ourselves the question, what do we need to multiply 1 by in order to get 12x squared? What do we need to multiply this denominator by to get 12x squared? We are going to ask the same thing here, and we are going to ask the same thing there. What do we need to multiply 1 by in order to get 12x squared? So we use the LCD to basically make the current denominator of each fraction to become like the LCD. So what do we multiply this 1 by in order to get 12x squared? Okay, we don't just multiply by 12, but we multiply by 12x squared. Okay, but what we do at the bottom, we must do at the top. So that means 3x is going to be multiplied by 12x squared. Okay, because what we do at the bottom, we also do at the top. Okay. Next question. These are two terms. We make sure to put 2 or more terms in brackets when we have them in the numerator. Question is, what are we going to multiply 4x squared by in order to get 12x squared? What do we multiply 4x squared by in order to get 12x squared? No, brother, not by 3x. This is 12x squared. This is 12x squared. What do we multiply 4x squared by? Yeah, by 3. Okay. Brother, what's happening? And remember what you do at the bottom, you must do at the top. Okay. So that means we are going to say minus, write this minus sign. This 3, we are going to write this side and then say x cubed minus 2 plus this plus sign. What are we going to multiply 12x by in order to get 12x squared? Exactly. What we do at the bottom, we do at the top. So that means we are going to say 1 times x. Now if you think about it, all of my denominators are now like the lowest common denominator. All of my denominators, I have equivalent fractions. Using the LCD, I've now formed all of my denominators to become like the LCD. So I'm going to write 1 common LCD, which is 12x squared, because I have formed the denominators to be like the LCD. And the rule of fraction says, once the denominators are the same, you keep the LCD. You can now add and subtract the numerators. So now I'm going to go and multiply out 3x times 12x squared. What is 3x times 12x squared? What is 3x times 12x squared? 36x cubed. Very good. Then you have a negative 3. Remember, That 3 was this side. But we know that multiplication is commutative. In other words, placing the 3 this side is no different than placing this 3 on this other side. Because 4 times 7 is the same thing as 7 times 4. Very good, it changes nothing. So now remember, the 3 which is multiplied adopts the sign that is negative that was before the two terms, which I used my wisdom and I put these in brackets so that I can know that the 3 needs to be distributed inside the two brackets. If I did not put brackets, I would have not seen the importance of distributing this 3 with the negative inside the bracket. So it's important that when you have 2 or more terms in the numerator, you put those in brackets so that you can be reminded that the sign, as well as whatever is before the number, needs to be distributed inside the bracket. So what's negative 3 times x cubed? Bravo. What's negative 3 times x cubed? What's negative 3 times x cubed? Very good, negative 3x cubed. Then what's negative 3 times negative 2? Very good, positive 6. Then you have the plus sign. What's 1 times x? All over the lowest common denominator, which thankfully we were able to get, and it is accurate. Finally, you look at your numerator, you add and subtract like terms. You can do that because the denominator is the same for all 3 fractions and it's common. So 36x cubed minus the 3x cubed, those are like terms. What do we get? X cubed minus 3x cubed is equal to what? These are like terms, so we add and subtract like terms. Very good, 33x cubed. We write the next x term plus x plus 6. We cannot factorize this any further, and it's all over 12x squared. So we leave our final answer as such. Okay, finished. Okay, so that's one example. I'm gonna do one last one. Well then, why did you ask me to do this if you know how to do it? That's my question to you. Okay. You obviously know how to do algebraic fractions. So why did you ask? You was unsure. Okay, that's fine. Let's do one more. Let's do two more actually. 3 plus 2x plus 4 over x minus 2 plus x minus 4 over 2x minus x squared. So let's do this one. Okay. So step number 1 here, what do? We have 3 plus 2x plus 4 over x minus 2 plus x minus 4 over 2x minus x squared. Okay, we can factorize the second one. Okay, so before we jump there, let us first reveal the denominators that we do not see. So x minus 2, we factorize, meaning we take out the highest common factor, which is 1, and we write x minus 2 in brackets. This was initially x minus 2, but now when we factorize, it becomes x minus 2 in brackets. It's one term. We move on. Plus x minus 4 over 2x minus x squared. We apply the order here, the x squared term, the 2x term last. So what we do is we apply what we call the sign change rule. X squared is negative, right? 2x negative x squared. Okay, so we take out a negative sign, we swap x squared and 2x, and basically if you take the negative, you multiply it back, you get back negative x squared. Take the negative, you multiply it back to negative 2x, you get back the positive 2x. So we are taking out the highest common factor, or we are taking out the negative sign. We are applying what we call the sign change rule. This positive and negative sign positive times a negative leads us to a negative sign. We then factorize x squared minus 2x. You're factorizing x squared minus 2x. Okay. How many terms? 2 terms. Is there a highest common factor between x squared and negative 2x? X into x minus 2. Okay. And remember that negative sign is going to change that positive sign to negative. Okay. So now all of our denominators, guys, no, x squared minus 2x is not the difference of two squares. No. KB, absolute rubbish. Okay. Not to offend you, but remember that the difference of two squares is when you have a difference. Yes, x squared is a perfect square number. 2 is not a perfect square number at all, so you cannot say it's a difference of two squares. Remember, a perfect square number is a number formed by multiplying a natural number by itself. This 2 is not formed by multiplying a certain natural number by itself, so it's not difference of two squares. Be careful in what you say. I don't know if you're saying what you don't mean or whatever, but be very careful. Okay. So our factorization is now complete. What is the next step? So step 1, we always need to factorize. Okay, no problem. No problem, KB. No problem, KB. Factorize the denominator. That's always where we start. If the denominator we're able to factorize it. Okay, we have different types of factorization and we need to be aware of all of them. Okay, I always say if in the numerator you have 2 or more terms, put those terms in brackets. So 2x plus 4 I put in brackets, x minus 4 I'm gonna put in brackets. Okay, 3 is just 3, so it's not 2 or more terms, so that's okay. Now the next step, so factorize, apply the sign change rule when necessary, like we did here. We applied the sign change rule, took out a negative, reordered the terms. Okay, we always do that when there's a negative sign and we can see that the last term is the variable that has the highest exponent and there's a negative sign in between. You can apply the sign change rule, take out the negative, fix the order, and then the negative times the positive will give us one sign in between the two fractions. We resolve the sign. We can now factorize x squared minus 2x, take out the highest common factor, we're left with x minus 2. So now all of our denominators have been factorized. We put 2 or more terms in brackets. Guys, I do this almost explicitly as a rule. Put 2 or more terms in brackets. Now step 2, find the LCD. So browser, what will be the LCD here? What will be the LCD? Number, letter, bracket, if you remember, the product. So what will be the LCD here? What will the LCD be here? What will the LCD be here? What will the LCD be here? I want the entire LCD. Okay, listen to me and listen to me well. We first look at the number. So where's the number? We have 1. Okay. Before the x minus 2, we have a 1. And then here, before this bracket, before the x, we have 1. So as far as the numbers are concerned, we're looking at the coefficient. We're looking at this one, the one before the bracket, and the one before the letter. So the lowest common multiple between the numbers, between 1, 1, and 1, we know obviously will be 1. Then we multiply that with the letter. Now, what is the lowest common multiple letter? Remember we said with the letter, we are still looking. Look at this denominator, there's no letter. Look at this denominator. We are looking at if there is a letter before the bracket. We're not looking at the bracket, we're looking at before the bracket. Guys, when we look at the number and the letter, we are looking at the number and the letter. If the number or the letter is alone, we look at it. Or if the number and the letter is before the bracket, we are looking at it. So So the lowest common multiple number between 1, 1 and 1 is 1. The lowest common multiple between the letters, we are looking at this, there's no letter. We are looking at this bracket, before the bracket, there's no letter. We are looking at this, before the bracket, there is a letter. What is the letter? That is before the bracket. The letter of the alphabet that is before the bracket. What is the letter? The letter is X. This is the only letter that exists. And with the LCD, we do look at leftovers. I regard this X as a leftover. It is the lowest common denominator that possesses the highest exponent. So what I'm going to do is I'm going to multiply the 1, which is the number, with X, the letter. The X is unique, and it is the common base letter with the highest exponent that exists for all 3 of these denominators. So I'm taking it. Then I go to my lowest common multiple bracket. Here I check for the bracket that possesses the highest exponent. It must be unique and possess the highest exponent. So if I look at this fraction first, it does not have a bracket. But if I look at this denominator, it has a bracket that is x minus 2. What is the exponent? It is 1. If I look at this one as well, it has x minus 2. What is the exponent? It is 1. You can't see it. So this is a common bracket. So it means I am going to include that common bracket as part of my LCD. And because it is common and it has the same exponent, I'm going to write that as my common bracket once. So all in all, my LCD is x into x minus 2. This, guys, is my LCD for 1, x minus 2, and x into x minus 2. The LCD is x into x minus 2. Okay, so I hope we are together here. How we got the LCD? The product of the lowest common multiple number, the lowest common multiple letter, and the lowest common multiple bracket. Number, we look at the number alone, the number before the bracket, the number before the variable. We compare, we ask what is the lowest common multiple. It is 1. The letter or the variable, we look at the variable if it exists. Here we don't have it. Here we're looking at the variable before the bracket. We don't have it. Here we're looking at the variable before the bracket. We have 1. It is what? X. It is unique, and it is the variable with the highest exponent that exists for all 3 of these denominators. We write down that letter because it has the highest exponent and it is unique. We go to bracket, common bracket with the highest exponent. We don't have a bracket here, we have one here, and we have one there. These are the same, they are common. We choose 1 once, common bracket with the highest exponent, it's x minus 2. The product of all of these, number, letter, and bracket, gives us x into x minus 2. That is our LCD. Now, when we get and we know what the LCD is, it means that we have a common LCD, which is x into x minus 2. We can write all 3 of these fractions having this lowest common denominator. All we now need, step 3, is to write equal equivalent fractions using the LCD. Right, equivalent fractions using LCD. So for the fractions that we have here, we need to establish equivalent fractions. What do we mean by equivalent fractions? Fractions that are equal, that possess the denominator, the LCD, x into x minus 2. So we are going to play who's missing, who needs to be added. Who's missing, who needs to be added. So if we look at 1, this is the current denominator. We want to have this denominator in the place of 1. So the question is, who is missing? Who do we need to multiply 1 by in order to get this? What do we have? We have 1. Who is missing? Remember, 1 was there. Who is missing? They are missing. X into x minus 2 is missing. So we are going to multiply 1 by x into x minus 2 so that we have this denominator for this fraction as well. But remember, what you do at the bottom, you must do at the top. So we are going to do the same thing at the top, multiply the 3 that you have there by what? What was missing in the denominator, which was what? X into x minus 2. Okay. Are we done with the first fraction? Yes. Let me just recap again. What did I say? I said we want an equivalent fraction of 3 over 1 that has this denominator. So that means we are going to multiply 1 by what in order to get x into x minus 2? Well, we're going to multiply by the entire thing. But what we do in the bottom denominator, we must do to the top. So if we multiply by x into x minus 2 at the bottom, we need to then multiply this 3 by x into x minus 2. There you have it. 3 times x into x minus 2 at the top as well. Let's go to the second fraction. Plus, because there's a plus sign, 2x plus 4 in brackets. We go to our denominator, we ask, who is missing in order for us to have this denominator? Who is missing? We already have 1 and we have x minus 2. Who is missing so that we have this denominator in this here? X is missing. So that means I'm going to multiply the bottom by x. But what I do at the bottom, I do at the top. So that means I'm going to multiply this 2x plus 4 by what? By x. Okay. Minus x into x minus 2. This denominator already resembles the LCD. So no one is missing here. Alright. Okay. We would simply multiply by 1 at the at the bottom, and do the same thing at the top. So we can just simply write x minus 4. Okay, in brackets. Guys, I hope you see what I've done here. These are equivalent fractions because the rule in fractions says we can only add and subtract fractions when the denominators are the same. We can only add and subtract fractions. This only applies to addition and subtraction of fractions when the denominators are the same. So that is why the LCD is important. It allows us, or it gives us the chance to change the current denominators of the fraction to be aligned with the LCD so that addition of the numerator can take place. So we can only truly add and subtract fractions when the denominators are the same, and we actually only add and subtract the numerators. So we add and subtract the numerators. numerators means the top numbers, we keep the LCD. There it is. So that's why I just wrote a common LCD for all three fractions whilst basically checking who is missing. What I multiply at the top to form the LCD is what I need to multiply at the what I multiply at the bottom to form the LCD is what I need to multiply at the top. What I multiply at the bottom to form the LCD is what I need to then multiply at the top. What I multiply at the bottom to form the LCD is what I need to multiply at the top. So let's now multiply out, add and subtract the like terms. BODMAS says brackets, exponents, division, multiplication, addition, and subtraction. So this 3x we are going to distribute. 3x times x is going to give us 3x squared. Then 3x times negative 2 is going to give us negative 6x. 2x plus 4 I put in brackets. You see, so if you have, the rule says if you have 2 or more terms, I encourage all of you, when you have 2 or more terms in your numerator, put those 2 or more terms in brackets. Do that immediately, guys, after factorizing. Make sure that 2 or more terms are always placed in brackets, because when you do that, you will then be reminded that, okay, this is plus a binomial times a monomial. Okay? And this x, all right, okay, is actually x into 2x plus 4. Okay, multiplication is commutative. It's a positive x into 2x plus 4. So I'm going to also distribute this x inside here. Then it's a negative into x minus 4. I'm also going to distribute the negative sign inside the bracket. And so many times learners don't put brackets for 2 terms and then they forget that this negative sign should have been distributed or ought to be distributed. So let's be very careful. Okay, so let me finish off. Okay, I just wanted to make that point, that this is times x. But remember, guys, you would distribute this x. You would understand that this sign is supposed to be attached to the x and distributed inside the bracket. Okay, and then this negative sign, if I didn't put brackets, I would have thought that the negative sign only belongs to the x. And that's where sometimes the mistake is, that you don't put the brackets, you forget that the negative sign ought to be distributed. So let's finish off this. 3x squared minus 6x, x times 2x, and x times positive 4. What does that give me, guys? X times 2x, x times positive 4, x times 2x, x times positive 4. People are quiet here. Plus 2x there. Thank you, Ngachi. Thank you so much, Ngachi. And then x times positive 4. A positive times a positive. X times 4. Positive 4x. Then we come here, and negative times x is a negative x. And then a negative times a negative gives you a positive, so that is going to give us positive 4. X into x minus 2. Now we are going to scout out and look for like terms. Step 4. Remember, I said we can only add and subtract fractions when the denominators are the same, which is the case here. So what we do is we distribute, add and subtract like terms whilst keeping the LCD. So we are going to add and subtract like terms. Okay, so let's do that. And what you notice is that with my denominator, I am not multiplying the x into the x and x into minus 2. Okay, I am leaving it as it is. And my recommendation to all of you is that leave the denominator as it is. Leave it untouched. Leave it as a product of two things. Don't multiply it in yet. Just leave it as it is. Let's add and subtract the like terms. What's 3x squared plus 2x squared? Because 3x squared and 2x squared are like terms. Like terms have the same letter and exponent. So 3x squared and 2x squared are like terms. We can add them. 3 plus 2 is 5. The x squared stays that way. Negative 6x, 4x, and negative x are also like terms, so we're going to add and subtract those. Negative 6x plus 4x is 2x. 2x minus x is 1x, which is x. Constant there, plus 4. All over x into x minus 2. So now the only thing I am doing now is I'm looking at the numerator and I'm asking, can I factorize the numerator, okay, in such a way that it will lead me to brackets that will eventually lead to the cancellation of what is in the denominator? And when I'm looking at the numerator, I'm like, no, the numerator is not factorizable, because if I could factorize it and it would lead to the cancellation of what is in the numerator, in the denominator, I would go ahead and do so. But because none of it can, I basically end right here, and that is my final answer. Okay. All right. So those, okay, were, yeah, nice, beautiful stuff. I'm gonna do one last one. Okay, and then I'm gonna call it a day, and it's night, and get out of here. Okay, let's do this last one. Addition and subtraction of algebraic fractions, grade 10s. Yeah, some of you are crying that it's too early in the morning. I understand that is the case, but you see, those that win, they rise up early in the morning, they seize the day. So I am a great advocate of that, so I hope that you guys can take heart, go after your goals and go after your dreams. I believe that you can turn around your maths situation. If you are doing maths grade 10, you're starting it out this year, let me tell you this: every single lesson for term 1 matters. You better make sure you bring the right attitude in class every single day. And you better make sure that when you get out of that class, you make sure that you practice every single little thing that is being taught, so that you can make sure that you understand it for yourself. You must really take ownership and responsibility over your maths, because you want to get a very good level. And I mean, guys, level 7. Like, there's almost a air of, you cannot compromise level 7 anymore if you are doing pure maths, because if you want to do anything nowadays, you have to have good marks, man. You have to have solid marks, and not only just for maths, but sort of like all around for all your subjects if possible. Yeah, so anyways, let's do this last one. This is also a situation of subtraction of algebraic fractions. So the first step we've established now, sort of like a routine. That's step number 1. What are we going to do? We are going to factorize the denominator if possible. Apply the sign change rule if needed. We know that there are different types of factorization. factorization of a trinomial, difference of two squares, grouping, advanced trinomial, cubic factorization. We need to be familiar with all types of factorization so that when simplifying an algebraic fraction, we can factorize with ease. It is an absolute must for you to be 100% sure of all the different types of factorization, because if there's something that is a blind spot in factorization, you are going to suffer. You know why? Because of lack of knowledge. X squared minus 5x plus 6. We need to factorize this. So in the comment section, what do I get when I factorize this? We are following step number 1. Factorize the denominator. The number before x squared is 1. So this is a quadratic trinomial. Alright. The highest exponent for x is 2, followed by the x term, followed by a constant last term. Ben Lev, thank you so much. I see you in the comment section. X minus 3 into x minus 2. Alright. Why is that the answer? The last term is positive. Kachi? No, not x minus 2 into x plus 3. Be very careful, guys. When the last term is positive, you see the factorization rules are not being observed there by Kachi. When the last term is positive, the constant term is positive. That means when you open two brackets for factors that exist, you are going to have the same signs. Guys, a positive sign always means that you are going to have the same signs inside your brackets. A positive constant last term means you are going to have the same signs inside your bracket. Guys, the word same means alike. You are going to have the same signs. But which signs? This sign, we are going to have the same signs according to the sign of the middle term. So a positive last term means what? Same sign. So when you see a positive last term, you must think of same signs. But if it was a negative constant, then you would think of different signs. So I don't ever want to see someone factorize a quadratic trinomial expression and then think that when there's a positive, it is allowed that you have different signs. No, guys. If you are doing that, it means you are not really observing the small rules attached to different problems when you are doing them. Okay, so positive last term means same signs. Then you ask, according to who? According to the sign of the middle term. I usually say to my learners that this plus 6 is like the father of the house. Guys, I don't care if the father of the house, the husband, is positive that morning. Do you know who will change that mood very quickly in that house? This term, I usually call this the mother. The mother dictates the mood of the home. So if a father is positive, you know, inside the house what happens? Whatever the mother is feeling like, I'm telling you, man, it happens like clockwork, that thing. So if daddy dearest or hubby dearest is all up in a good mood, but mom is not feeling it, rest assured, guys, that the mood in the household will be according to the mother. So I usually say the positive sign, yes, means same sign, but who governs the mood in the house? The mother. So if the mood is negative, guys, the mood in the house, I promise you, is going to be negative. That day, supper is not going to go great. That day, like just a lot of things. The kids are going to feel it. Dad is going to feel it. Everyone in the house is going to feel it. So what I'm saying is that positive means same signs. According to who? According to the mother. Negative, negative. If the mother is positive, according to the mother, this would be positive, positive. So positive sign, guys, please, your constant last term, if it is positive, it means same signs. All right, please, same signs according to the sign of the middle term. Then you think of factors of 6. When you multiply these, you need to get positive 6, but when you add them, you need to get negative 5. So you have 6 and 1, they are both going to be negative. When you add them together, do you get negative 5? No ways. You have 3 and 2. When you add them together, do you get negative 5? Definitely multiplying them will give you 6, but when you add them, do you get negative 5? Definitely yes. So it's negative 3 and negative 2. To get x squared, you simply say x and x. So please, guys, let's be mindful when we factorize. Okay, I need everyone who is doing algebraic fractions to know very well all the different types of factorization and to master them. So factorizing the denominator is our first step. We always factorize the denominator, but we must know the different types of factorization. Remember this, the drill of example of mother and father is just to help those. Okay, some people get the rule, but I'm just trying to make it palatable so that people can see it for what it is. Okay, for negative, it's a different story, because negative, okay, means different signs. All right, but then this sign will always be given to the sign, to the highest factor for the factors of the last term. So we just need to understand the different rules as they apply for different situations. Okay, let's come here, guys. We have x over x minus 3, the whole thing squared. This is already factorized, because x minus 3, it means that there's two of these brackets. So x minus 3, the whole thing squared. Now, step number 2, the LCD. What is the LCD of x minus 3 into x minus 2 and x minus 3, the whole thing squared? Guys, remember I said LCD, we write it according to the number multiplied by the letter multiplied by the bracket. Okay, the number, which is always outside the bracket, the letter, which is outside the bracket. So these two should feature outside the bracket. We are checking for the number and the letter that is outside the bracket. So let's come here. Do we have a number outside the bracket? Yes, there's a number 1, you don't see it. Do we have a letter outside the bracket? Yes, there's the number 1, you don't see it. So the lowest common multiple number between 1 and 1 is 1. Then we move on to the letter. Is there a letter outside the bracket, a letter of the alphabet outside the bracket? No, we don't have a letter. So we are clear for the letter, no letters outside. Then we go to the bracket, the common bracket with the highest exponent, as well as your bracket that is a leftover. Guys, can I just address this? For this fraction, there's a x minus 3. For this fraction, there is a x minus 3. So x minus 3 is a common bracket. But between x minus 3 and x minus 3 squared, which bracket has the highest exponent? We agree that x minus 3 and x minus 3 are common. But between x minus 3 and x minus 3 squared, which one has the highest exponent? That is the question. X minus 3 and x minus 3 are common, we agree. But which x minus 3 has the highest exponent? Is it for the first bracket, or for the first fraction, for the second fraction? Okay, so I'm sure you can see, guys, that the common bracket with the highest exponent is going to be x minus 3 the whole thing squared. Then we look for any other unique bracket that I usually say, guys, these are leftovers. X minus 2 is unique for this fraction alone. It is not common for both fractions. So we call x minus 2 a leftover. So I usually say L for LCD also means you consider the leftovers. Leftovers are brackets that are not common for all fractions. I repeat, leftovers are brackets that are not common for all fractions. It literally is a leftover x minus 2. So as x minus 2, it is unique. It is the only one that has an exponent that is the highest as x minus 2. So that means I'm going to include x minus 2 as part of my LCD bracket. So for my brackets, I have x minus 2 into x minus 3 the whole thing squared. The LCD is x minus 2 into x minus 3 the whole thing squared. This is the LCD. Once I have that, then I'm ready for the next step. Are we together, my good people, in the comment section? Are we together, my people in the live? In the next 15 minutes, I'm going to be out of here. But I need you guys to know how to identify the LCD, because the minute you are unable to identify the LCD, that is where the problems start and begin. Okay, so after factorizing, you are going to check for the lowest common multiple number. Where did I say this number needs to be? It needs to be outside the bracket. So you check, do I have any numbers outside the bracket? Well, I do. It's 1 and 1. What is the highest common multiple letter? It also needs to be outside the bracket in order for me to identify it. And it is always the common letter with the highest exponent, as well as your leftovers that are basically unique. We include them if they are available. But we can see outside these two brackets, there are no letters. We move on to the common bracket, the lowest common multiple bracket. We ask ourselves, what is the common bracket with the highest exponent? X minus 3 and x minus 3 are common. Which one has the highest exponent? It's x minus 3 squared. So it means we include that in our LCD. But for the brackets, we also consider what we call the leftovers. L for LCD also means leftover brackets. So we check out a bracket that may not necessarily be common for all fractions, but may be common on its own. So we identify that. We check if there's no other x minus 2, but this x minus 2 is unique. It is the only one. We include it as part of our LCD. This is my lowest common denominator. What is the next step? Step number 3. I am going to write equivalent fractions using the LCD. I am going to write equivalent fractions using LCD. This simply means I'm going to look at this denominator and check who is missing, because I want this denominator to become like the LCD. I want this denominator to become like this LCD. So I'm asking now, who is missing from this denominator in order for it to become like this? So x minus 2 is there. X minus 3 is there. But there is 2 of the x minus 3. Here I have 1. So that means I am missing what? 1 x minus 3 is missing. But remember what I said to you guys even as well. I said if you have 2 or more terms in the numerator, please put 2 or more terms in brackets. It will save you. This is one term. Okay, I'm just going to leave it as it is. But these are two terms, x3, x minus 1. So I'm going to put 3x minus 1 in brackets after getting my LCD. So what did I say? Who is missing in this denominator? There's an x minus 3. There's an x minus 2. Here in the LCD, I have 2 of the x minus 3s. I have 1 x minus 2. So who is missing? I am missing 1 x minus 3. So let's make life very nice. I know at the end that I want these denominators to be fashioned after my LCD. So let's just write the LCD so that we are finished and done writing the LCD. This will be for both these fractions. Common for all fractions. Thank you, Z, for the you awesome. I said, who is missing? X minus 2, I have an x minus 2. X minus 3, only 1, I have x minus 3, 2 of them. So that means I am missing here an additional x minus 3. Okay, but remember guys, if I'm going to put in that x minus 3, then it means at the top, in order for me to have my equivalent fraction, I'm going to have to multiply by x minus 3 there. So this is what I write here. I write 3x minus 1 into x minus 3. For my first fraction, guys, the equivalent fraction is complete. I have used my LCD to write the denominator I had so that it is like the LCD. I was missing an x minus 3 in the denominator, therefore I take the same x minus 3, I multiply by it in my numerator. There it is. I'm going to be busy very soon with these two brackets. Let's move on to the second fraction. In this denominator, I have 2 of the x minus 3s. Just like in the LCD, I have 2 of the x minus 3s. Who is missing though for me to have the same LCD? Who is missing here? Who is missing here, guys? Who is missing here? Who is missing here? I get anxiety when I hear x. Sorry about that, Tando, guys. Who is missing here? Who is missing here? Yes, Ngachi. X minus 2 is missing here. So x minus 2, I'm going to put him there. Okay. But what I do at the bottom, guys, because remember, I am forming what? Equivalent fractions. What I do at the bottom, I have to do at the top. And you see, I put it nicely in brackets. So that means in my step here, I'm going to say minus. Remember, there's a x. But then I'm going to multiply it by what, guys? By x minus 2. Having written the LCD for both my fractions once, that allows me now to go ahead and do what? Add and subtract the numerator. Because that is the rule with fractions. You cannot add or subtract fractions until the denominators are the same. So we use the LCD to make sure that we form denominators that are like the LCD. But guys, the LCD needs to be correct in order for us to do that successfully, right? The denominator needs to be fine. The LCD needs to be correct in order for us to be able to do that. Okay, I haven't been able to explain it in this simple form to my daughter. Thank you, sir. Oh, you're welcome. You're welcome. You're really welcome. Okay, now we can proceed with the next step. We've written the equivalent fractions using the LCD. Remember why? We can only add and subtract fractions when the denominators are the same. So now what can we do? We are going to apply BODMAS, multiply out and add and subtract like terms, and then we should be good. So 3x minus 1 into x minus 3. Let's play the maths game. We multiply 3x with x, 3x with negative 3. Let's go. What's 3x times x? That gives us 3x squared. Then what's 3x times negative 3? A positive times a negative is a negative. 3 times 3 is 9. the x straight next to the 9. Okay, let me repeat that again. 3x times x, you distribute. We are applying something that we call the distributive law. Take 3x multiplied by x, you get 3x squared. Take 3x multiplied by negative 3, you get negative 9x, because a positive times a negative is a negative. 3 times 3 is 9, the x next door to it. Then after we are done with 3x, we take negative 1, we do the same thing. Negative 1 times x, a negative times a positive is a negative. 1 times 1 is 1, and then the x next door. Negative 1 times negative 3. A negative times a negative is a positive. 1 times 3 is 3. We are done multiplying out using FOIL, FOIL, distributing each respective term fully and completely to the term in the other bracket. Now, the last thing we need to do, this negative sign, guys, is going to be distributed with x inside the two terms in this bracket. What's negative x times x? That's negative x squared. When we are multiplying same bases, we keep the base x, we add the exponents. There's an invisible 1 and a 1 that's there that you don't see. You add those exponents when you are multiplying same bases. Then a negative times a negative, that's a positive. X times 2 gives you 2x. Our denominator, LCD, is nicely formed. And guys, we leave this denominator as brackets like this. You don't multiply out the denominator. All you care about multiplying out and adding and subtracting like terms is in the numerator alone. Leave this as it is, guys, please. We add like terms at the top. What's 3x squared minus x squared? 3x squared and x squared. The x squared and x squared term are like terms. So when we add and subtract like terms, we keep the letter with its exponent. We add the coefficients. 3 minus 1. There's a 1 there. What's 3 minus 1? It's 2. Negative 9x, negative x plus 2x. Guys, there's a tendency Lena is getting this wrong. So please, when you have the calculator, please use it. Alright. Now we know that the x is going to remain, right? Nothing's going to change with x. Now what we want to focus on is the numbers. Negative 9, there's a negative, there's a 1 there, there's a 2. So negative 9 minus 1 plus 2. So you can just say negative 9 minus 1 plus 2. Be safe than sorry, please. Just be safe than sorry. Be safe than sorry. So it's negative 8x, right? And then the last term there, we don't have any other constant term, plus 3. Okay, plus 3. Okay. Hey guys, I hope it makes sense, this thing. I hope we are making sense. Are we understanding this, guys? Are we understanding this? Okay. And that's all over. X minus 2 into x minus 3, the whole thing squared. Now in some cases, this is factorizable, and when it is, you know, sometimes it will have a common bracket with something here at the bottom, and then you can simplify further. But in this current situation, guys, this here, we will not be able to factorize in such a way that we will get factors that are similar with what you see there in the denominator. Right? So then that means we are going to leave our answer like this. Okay, that's done. Right. Okay, so hopefully this last session was good. People were able to get something and learn something and gain something. Very important for that to be happening. All right. I think now I need to vamos, love and leave you. But yeah, see me again tomorrow morning. I intend to kind of really get up early in the morning and do maths when situations allow. But thank you so much. I hope that this has been helpful. And yeah, I'm even proud of those parents that are actually doing this not for themselves but for their kids. That's props to you. Wow, guys. I take my hat off to those parents that are doing such. It's amazing. All the best to me. Thank you so much. I really appreciate it. Have a good day further. Enjoy. And yeah, see you when I see you. As I said, guys, if we were able to factorize it and it would lead to the cancellation of something in the bottom, we would do it. Because remember, we did division of fractions or division of algebraic expressions as well. And when we did that, if factorization can happen in the numerator in such a way that it leads to the cancellation of what is in the denominator, we do it, and then we're able to simplify that further. But in this situation, guys, this is the end. This is where we end.